So I think the following. So in this C drive in the data folder is where the data acquisition software is, and there are a couple of different versions. I think this is the one we want, right?
Yeah, that was the latest.
Latest date.
Date.
So I'll create a shortcut.
Okay.
Desktop there for you. So here's leftover from Chan's last run. So the idea is, and then we can also pull up, while we're at it, when we pull up the Oxford software. So if I go back to the C drive, there's an Oxford folder. And which one is it? Is the, if I just run that, will IDH
yeah, I think that one will work. Yeah, the right up one is that one.
Let's see what happens.
Okay. This one with yeah.
Okay, so this is the IGH fundamental TCP, I guess, that started. And this, for example, it may have taken over control, yeah. This is now on remote, the reader. So, for example, I can open this file here. It opens it now in a minute. So it's just it's a reproduction of what's on there. Then one of the nice things about this is I can monitor the sorb temperature of the 1K pot and mixing chamber all simultaneously. And then I don't have to switch between these various things. Other than that, there's and then you can also, we can put the set temperature on here and stuff, which we can do manually. All this stuff we can do manually, but it's nicer to have the readout in there. So we'll just keep that running in the background. Well, let's go back to the data acquisition software. So the first thing we want to do is, if I go, let's go to this data folder in here. So basically, it's going to, in a given run, we're going to take a number of different data files, take a number of different traces and different experiments and things like that, and it's going to save each of the experiments in one of these zip files that are here. So here's the one that I think is running right now, and so it'll continually. It'll start at number, at the first data file, and you can say that in the second data file. And each one of these will contain a number of data files from the whole run. So the first thing we want to do is want to create a new one of those data files. If we started running now, we'd still be in this old data file. So the way you do that is a little tricky. You just got to save as. Mm-hmm. And then it asks you to name what you want that zip file to be named. So we usually put last name in there, and then you might want to put SFS and then a date or something like that. Don't use backslashes in the thing, it might confuse it. Okay. Were you going to say, Jay?
No, I was just saying the same thing. We can put backslash.
Yeah.
For the file.
So start off immediately and it labels this. So here's your title, and then in parentheses is 2. So every time we save a data file, save a data file, it'll save it as one of these numbers. And it always starts off with number 2. Number 1 is the sort of directory file, and so it goes 2, 3, 4, whatever. And then the next thing is if I want to clear, if I take data, or if I have data that's already there, I'm going to clear it off. What I can always do is new tableau, more control N. So that's going to clear, so there's all this data that's in the buffer here, which I could either save, or I can clear it off, and since it's not our data, I'm going to new tableau, so it erase the data. So it's important, so you can be taking data and it can do these traces, and then at any point you can always go save data file, and it will save what the trace on the screen is. If you go to New Tableau, it'll erase all the data you just took. So maybe you take something as a test and you don't want to save it, and you just go to New Tableau. Maybe you take something and you want to save it, and you continue to take it and you save it again. This program crashes somewhat frequently, but it is very good about remembering the data that was in the buffer. So when it crashes, even I think if the computer is shut down, it's pretty good at remembering what the data is there. So it's hard to lose the data unless you clear it accidentally when you wanted to save it.
Yeah.
So now we need to set up our measurement here. And usually the first thing I go to is instrument setup and edit the GPIB file. So what this is going to do is it's going to be a list of different instruments and their GPIB addresses. Right? And so this is just a number of however many instruments we have, 1, 2, 3, 4, 5. We have 5 instruments. And then there's a whole host of different instrument names for the different pieces of equipment we have. Yeah. And then we have to figure out what the addresses of the particular pieces of equipment are, what those are. So we're going to be using for example, the Keithley, and I don't know which one it is, 1 or 2. But anyway, it says.
Yeah, maybe there's a mark on the front panel. I forgot, but probably just try and see if you can.
I don't think it matters which one it's actually named. Does it say 1 or 2? Anyway, but do you know what the address is? So there is a number 1 on there. I turn this on. It's a 16 there, so it's stress 16. So if we type in, I guess I have to go to 16, and then go to update file, and so that should now save that in there, 16. And then the next thing we need is we need that current. We're going to need to read it, right? So the things we have to put in are, you're going to be taking measurements with your lock-in, right? Yeah. So that's going to be read in one of those multimeters over there. So you have to put at least one of those multimeters over there. And then we're going to be reading the currents going to the magnet, which is going to convert to a field measurements using this, 3458. And again, I think this is address 9 on there. So
maybe just press DCV.
That's address 9. These I all happen to know are how they're labeled. So which one are you using to measure the lock? Are you using this one? 5. Okay. So the 9 here and the 5 there. So that's it was 3458A, is that one?
Okay. Go.
So here's the magnet specifications for this magnet. There are 2 magnets, the solenoid and the split pair, right? One goes this way, one goes that way. We want the one that goes this way. So that's the split pair.
Yeah.
And then there are a few different things we need to know. So the rated current, for example, 25.3 amperes. So that's the maximum current that put down there. So we need to avoid that. Well, I think we'll get close.
Okay.
That's fine. And then there's the charge rate, how many amps per second you can put in. So this is the thing is, even if we were only going up to, let's say, half an amp, if we went from 0 to half an amp in a second, that might be a little bit too much for the magnets. That could be a problem too. So we need to make sure we go. The other thing is that heater that turns on and off that shunt, there's some amount of wattage or current that it needs to run through it in order for it to work. So that's this. But Jen's already set up that heater box so that it can supply that necessarily. So the main thing we need now is the field to current ratio. So because we're going to be measuring the current we're sending down, and we need to convert that to the field. Right? So it's giving us 395.25 gauss per amps. All right. And then we need to figure out, well, right now that current